and good evening, morning, afternoon to everyone watching this video as well. I just thought it would be not a horrible idea to go through quickly on the basics of the unit circle, because in math it's quite easy to forget when we did trigonometry a while ago. However, it might come useful sometime soon, especially on the non-calculator exam where you might need to recall some trig values on how to solve like certain things, and it's probably worth just a recap if you need it on how the unit circle works. So with that, all that being said, I'm going to dive straight into it, and it's going to be very quick. So what the best way to think of it is that we have a Cartesian plane. Okay, let's just draw a rough little Cartesian plane. Okay, not perfect, but it'll do the job. Okay, and now what's gonna happen is we're gonna have a circle. Okay, the circle that we're gonna draw is gonna come onto the plane, and it's gonna come about we'll come up a bit, maybe that big. And with the unit circle, we're gonna go to here, and it's gonna be an increment of 1, -1 for basically all sides, where you're gonna come to 1, -1 on your x, you're gonna have +1, and you're gonna have -1 down here, and these are at all these intercepts here. Then you can have any point defined on the intersection here, which we can call point P, where its coordinates are going to be some x value and some y value. Within some x and y value, it can be said that the x is going to be equal to the cosine of whatever angle is here. So this angle here is going to be called theta, okay? And now what we can say is that we can draw like a line, okay? This is going to help you visualize it. As any point here is 1, -1, okay, so it comes out to 1. We could also say that the radius would be 1, okay, because from here to here is 1. So the hypotenuse is always 1, okay? Now cosine is equal to adjacent over hypotenuse, okay? Or in this case is equal to adjacent over 1, which would just be the adjacent, okay? Now in this case, the adjacent of this angle, right, of theta would be here. So that is going to be our x. So x is equal to cosine of theta, cos theta. And your y is going to follow a similar thing, but instead of cos, it's going to be the sine, okay? And for the same reason, that's going to be opposite over hypotenuse. The opposite here is going to be divided by 1, so it'll just be the opposite, which will be the same angle. So now we have a definition for that point pxy, where it's going to be p is going to be equal to cos theta sine theta. And now, having this definition here, it is very useful in order to solve for certain math problems that you have. So like we now have that, right? And we have the understanding of that. But the better way that I think to do it is you should get familiar with this table, okay? It has sine on the top, cos next to it, tan on the third one. Don't worry too much about the tan one for now, you can come to that later. But we'll worry mainly on the sine and cosine one. So you have, let's say you have 0 degrees, okay? You start the unit circle at 0 degrees, which is here, flat, 0 degrees. You're gonna have 30 degrees, there's one. 45 degrees, there's one. 60, there's one. And 90. So these are all the angles that really matter. But out of all them, the most important ones that you should really know, because you can just look at the unit circle and you can get the value for 0 and for 90. For 0, right, you look there, and 90 obviously up there. But these other couple you should know. Let's start with sine 0 first, okay? So the sine of this angle is basically how much in y is this point here. Well, obviously this is x equals 0, like this is the horizontal axis, so it's going to be 0. But for cos, right, it came out a whole point, so cos is 1. And now tan is equal to sine on cos, and 0 divided by 1, I believe you can't define, so it's undefined. Okay. The other easy one, 90 degrees. In that case, you can see that it's plus 1 on y, so your sine is going to be equal to 1, and obviously your cos here is at 0, so cos is 0. And then 1 on 0 is also undefined, so we can leave that as that. Okay, now the main values that are important are basically derived from a few triangles, but it's more easier just to remember the values, and I found a really cool way of memorizing these. So, especially for sine and cos, they apply for sine and cos really well. So, for sine 30 degrees, okay, it's root 1 on 2, okay, and if you know math or your surds, obviously root 1 is still 1, but I find it easier to remember it like this initially. So you've got root 1 on 2, 45 degrees is root 2 on 2, and then 60 degrees is root 3 on 2. And the awesome thing about cos, right, is it's that series of numbers reversed. So it's root 3 on 2, root 2 on 2, root 1 on 2. Right? And if you really wanted to be, you really want to see something cool, this value here, you could actually write as root 4 on 2. Because what happens with root 4 is the square root of 4 is 2, and 2 divided by 2 is equal to 1, right? And same thing here, this could be root 0 on 2, which would also be 0. And obviously same thing there. But yeah, that's pretty cool. Last thing to know about tan is it's sine divided by cos. So if you ever forget it, you can just do divide these two numbers by itself. But the way that you can remember it would be root okay, I think it's 1 on root 3, 1 root 3. And the cool thing is, imagine your root 3 starts at the bottom, it then becomes the denominator, and then it comes to the top. All of your 1 shifts down to the bottom. It can be 1 on root 3, 1 root 3 on 1. But yeah, that's basically all the exact values you need to know. And the cool thing with the unit circle is that these values work with anywhere on the unit circle. So let's say we have a question, and it's exact value, okay? We want to know the exact value of something. And in this case, our exact value we want to know is, let's say, we want to know the sine of 120 degrees, okay? So, first of all, what we can do is we can recognize that 120 degrees, right? 180 take something is going to equal 120. 180 minus x equals 120. So our x value is going to be 60 degrees. Okay, cool. So what that means is that sine 120 out here, we have that as 60 degrees. And the nifty thing about the unit circle is that this value here, whatever value it is here, will share a very similar, it will share the same answer, but it depends on the sign of where it is. And by the sign, I mean positive or negative. So it's going to share the exact same value as a 60 degrees over here. So now all we have to do is find the value of sine 60. Sine 60 root 3 on 2. Okay, cool. And to get our final answer for 120, look at it, right? sine is reliant on the y axis, okay? Like how high it sits up. And see how 120 degrees is sitting up on the unit circle? It's going to be positive. If it was below, if the value was here, it would be negative. However, because sine 120 is positive, like up here it's still positive, we're going to go positive. And that's about it for the unit circle. It's pretty straightforward. Once you know this table and you understand how to break off exact values, it's all pretty straightforward from there. Hope that helps and you guys don't have any troubles with the unit circle.